So let's start off with that. This is your linear parent function, y is equal to x, f of x equals to x. Parent quadratic function is going to be y is equal to x squared, f of x is equal to x squared. So you need to know these two, okay? This is your parent function. So let's look at this one. Transformations means to change, guys. Like a transformer, how it changes. So we're going to apply translations to quadratic functions. We're going to do them. And we're going to apply dilation and reflections to quadratic functions. So you guys, you understand where you're at. You guys are in 9th grade math. Okay, you went from 6th all the way to 9th. 7th, 8th, you all skipped. You don't know that. So transformations, real quick, is just a change, real quick. Like a change. So we can have a triangle here, and you can slide it over. You changed it. Oops. That's a transformation, okay? We can get that triangle here, and we can turn it. It's the same triangle. We can get that triangle right there, and let me see. We can get that triangle here. Why is it not doing it? Oh, let me do something else. There's triangle there. We can get that triangle and make it bigger or smaller. Those are transformations. You understand that? Those are transformations. It's kind of like the same triangle, but it's not. What do you mean? So this triangle here, I make it change to it. It becomes a new triangle based off the older triangle. It is called like prime, the second one. All right, based off of that. Oops. Nope. So you can string it back down. Okay. Questions over that one? Transformation. That's a transformation. So we're basically going to go skipping these things. Transformation. Now it comes about a dilation. A dilation. Now, if you see this triangle here, let me copy this triangle here. I'm gonna. Just laying down some definitions. We're going to copy that and then paste it. So say this triangle, and I bring it over to that new triangle. We're going to do this. We're going to get this triangle, and we're going to make it bigger, maybe even get that triangle and turn it, flip it, whatever. We're going to do stuff to it, and that's what our thing is saying right here. We're going to apply dilations, make it bigger or smaller, and reflect it, turn it over, return, all these little slide stuff that we're going to do to it. And I'm going to tell you this much. This one's teaching you how to use it by reading it, by looking at it. Oh, realistically, you have a calculator. You can graph all of them, and you see what happens, what changes, what's going on here and there. So look, a transformation changes the position or size of a figure. When one transformation, a translation moves the figure up, down, left, or right. When a constant k is added or subtracted from the parent function, okay, parent function, you got to remember that. Parent function is this one right here. Okay, the parent function of a family of quadratics is f of x equal to x squared. The graph of the resulting is right here. The parent function, f of x, plus or minus some number. It translates it up or down. Yeah. What do you think translates it up? It's when you add a constant. What do you think moves it down? When you subtract a constant. Okay? And that's kind of like, you can say your y-intercepting kind of thing about it. All other quadratic functions have graphs that are transformations of the graph of f of x equal to x squared slash your parent function. So saying all functions that are quadratic come from the parent function. They just did something to it. So copy this real quick. Vertical translations. This is the parent function, guys. This blue one. Parent function. When they slide it up, they're talking about the vertex. How many units did it go up? When they slide it down, how many units did it go down? Okay? So the graph of f of x equal to x squared plus k is the graph of f of x, the parent function, translated vertically up or down. If k is positive, it goes up. If k is negative, it goes down. And that's it. So right here, we're going to have x squared plus, now I'll go with k. This one here, you have x squared minus k. Copy this down, guys. Get it done. Hurry up, please. Ooh. Yes, there is a sense of urgency. I'm going to run out of time if we don't hurry up. So vertical translations, guys, if you don't say anything, I'm considering that you know it. You got it. If not, hold on. So I need to copy it some more. Everybody ready to move? Everybody ready for me to move on? Again, your science is saying that yes. Okay, cool. Let's move on. So describe, and this is actually a star question. You'll probably get two of these, maybe two of these. Describe how the graph of each function is related to the graph of the parent function. This is the parent function, okay? They want you to describe. So how is this one related to the parent function? Okay, so remember the parent function goes to the origin, and it goes through 1, 1, negative 1, 1, and it goes up like this. So the parent function is x squared. That's it. What's the difference? Oh, they added 3 to it. So this is positive. It slides up 1, 2, 3. But we don't say slide up. We say translate it up. So we're going to say this one translated, or translation of 3 units up, translated 3 units up, 3 units up. Now, how we determine how much it went up is from this point, the vertex, to this vertex. So count from vertex, or vertex to vertex. So how far is it up? 3 units up, so it went 3 units up. On the other note, remember, if it was positive, it goes up. If it's negative, it goes down. So let's look at this real quick. This is the one they want us to compare. What is it that they want us to compare it? They want us to compare it to the original one, the parent function. Originally, it's x squared. Now they're putting the minus 4. This minus means to go down 4. So the original, the parent function, is right here. Look at this, going through the origin, going through 1, 1. Now, from here down 1, 2, 3, 4, you can see that it's down 4 units. Now, I'm going to show you this in the calculator. Okay, x squared. Come on. Oh, great, my calculator's asleep. Hold on. Come on, calculator. Go to graphs. Parent function, guys, don't forget it, is going to be x squared. So practice on your calculator right now, x squared. Now, to graph another one, I come over here, y'all can see, I press tab, and I'm ready to graph the other one. So then I would just type in x squared minus 4. Now you can see it's in a different color, and you can see the difference, how far up or down it is. If you want to be more like, how about more conscious of where the lines are and so forth, always go to menu. Everything that you need is in menu. Go to view, and you can turn on the grid, lined or dot. I'll just turn on lined, and now you can see that they're 4 units apart. This is going through that. Let me see. That one's going through negative, through 0, and then we go down negative 1, negative 2, negative 3, negative 4. There it is. You just figure it out like that. To graph another one, press tab, or if you need to come out here, adjust these, you can press tab and then go up, and now you can see the blue, red. If you need to change them or whatever, there it is. Going once, going twice. I'm going to get lost there. Again, your silence tells me you're good. And don't be afraid to ask questions, guys. I am here for you all. You all need help, you let me know. So we'll come back to the book. Okay, so this is my answer. G of x is translated 4 units down. Cool? Let's go ahead and try this one, guys. Actually, not try. Let's go ahead and graph these and say what's going on. We need to practice. You do need these. These are star test questions. These are kind of what you, what I say? How do I go down there? We'll have on your Alex questions, you will have these on your, 6-week exam and so forth, so we need to know them, okay? Again, the question's asking, describe what this one is compared to the original parent function. And I'll go out here and say parent function is x squared, okay? So let's graph the parent function. If you don't mind, graph the parent function. I'll be going through the origin, and I'll go through 1, 1, negative 1, 1, and it goes up like this. That's the parent function. And just label that one as f of x is equal to x squared. This one here is going to, ooh, what does that one do? Does anybody know? Does anybody know the answer already just by looking at it? Anybody know the answer for that one just by looking at it? If you do, now I want you to respond in the chat, guys. Tell me what happens to this one. Tell me what this one is compared to that one. Come on, let's go. Wow. Okay, Marlon, what's the answer for this one, Marlon? Allison. Leilani. Lexi. Jasmine, thank you so much. Thank you. I think Tristan got it right. 1, 2, 3, 4, 5, 6, 7. So this is where it goes, guys. This is the one that dead giveaway. It slides down 7 units. Okay? Jasmine, where are you at? 2, 3. I'm lost. Where are you getting these numbers from? So this, you know what? Let me change it. Let me change color. Okay? This one here, I'm going to graph in blue. It would go down 1, 2, 3, 4, 5, 6, 7. It would go here. And it would go, honestly, 1 unit to the left, right here. 1 unit right here. Imagine this same setup down here. Okay? Now, you need to be aware. This only slides to the up or down. It does not make it wider. It does not make it more narrow. It does not squash it. It does not stretch it. There's all these words that are going to come out later on. This one just slides it down. So we're going to go with translated 7 units down. Okay, guys, let's start answering the questions that I'm asking, because if not, I'm going to start crying home saying that y'all are refusing to participate, and I need you to participate more. I don't want to do that to you. Help me out. Let's graph this one real quick. Okay, I'm going to graph the parent function right here. Parent function, don't forget, it goes through 1, 1 and negative 1, 1. Great. What does this one do? Oh my goodness. Help me out. Anybody here can help me out? I know you all are busy writing and drawing, but I think you know the answer, right? Oh, now you got to type. So that's why I do pause a lot. I know you all have a lot of things going down. You have to put down your pencil. You have to look up. You have to look right. You have to look left. Jasmine, where did you get those numbers? I'm so curious. Where did you get 1, negative 6 and 2, negative 3? Where did you get those numbers from, Jasmine? Christopher, I really want you answering too. I need to know you know what to do. Jasmine, what's going on? You didn't answer the question. Where in the world is 1, negative 6 and 2, negative 3 from? What's going on? Ooh. I am so lost, Jasmine. Well, just stick to what I'm doing, okay? So this is the question. So again, that's the parent function. Please do not forget, that is the parent function, guys. This one right here. The one I'm going to use for this blue one would be like this. Go 1, 2, 3, 4, 5 up. 1 over, 1 up, 1 left, 1 up. And then it would go like that. And that one now is, honestly, 5 plus x squared. I don't like the way they wrote that. I would write it as this. F of x is equal to x squared plus 5. But they're just trying to trick you, so they switch these two around, okay? Thank you so much. Who answered that one so much? Awesome. Tristan, Lexi, and Jasmine, thank you so much for participating. Christopher, I'm waiting for you now. Don't give me that. Leilani, let's go. Dominic, let's go. Isabella, Kayla, Leah, you're not shy, Leah. Louis, let's go, Louis. Nathania, Ruby, Sophia, what's going on? Okay, graph this one, guys. Graph the original one. I'm going to do the original one. Can anybody tell me what the parent function is? Parent function, guys. Okay, tell me parent function. The parent function, guys. Come on. Somebody tell me what the parent function is here. Does anybody know what the parent function is? It's right here, guys. Right up here. So we're going to go right here. One right, one up, one left, up, right here. Here it goes. What does this one do now, guys? Tell me now. What does this one again is my parent function of x squared. Let's graph my translated one. What happens in this one, guys? Anybody know what happens in this one? Come on. Thank you so much, Christopher. 1, 2, 3, 4, 5. The vertex just goes like this. Pretty easy, right? And you know what I forgot? You got to forgive me. I forgot to write it over here. Translated 5 units down. This one is translated 5 units up. Okay. Now, we're going to finish here, guys. We're done for that. Let's move on to the next one. I'm looking at the time. We're running out of time. Let's go over here now. Ready? Now, horizontal. Horizontal. That means right or left. This one actually comes out. You will never, ever see this, guys, unless it's on a STAR test question. Unless they're actually telling you, hey, what's the graph going to do? I don't really care what it looks like because, honestly, for me, I'd probably come back and use the calculator. You understand what I'm saying? And see the difference. I need to know the original one, the parent function, then I need to know the new one, the one they're asking me to compare. You're going to kind of be aware of that. So let me come back to the book. If it's in this form, g of x is equal to x squared minus h in parentheses squared, then that h is going to be the translated right or left. If h, okay, is greater than 0, means positive, it goes to the right. If h is less than 0, then it goes to the left. Now, please pay attention to what they're saying. This setup is like this, x minus h. So if I have a 3, x minus 3, then in this situation, h is equal to 3. So that means you move to the right. What? I'll explain to you what I mean right there. Let's copy this down real quick. Please copy that down, see what you get. See if you understand what's going on here. Okay, the graph of this one is this one translated right or left. This graph is that one translated right or left. So I'm going to move it up. So look at this real quick. Now look at this. Remember, the form is x minus h. And here you can say h is 2, right? So that means h is positive 2. So I would slide it 2 units to the right. Here, this one, the form is x minus h. But in this situation, I have minus a negative. So in this situation, when it looks positive, it's really negative. And when it looks negative, it's really positive. So you got to keep an eye on that one. So in this situation, when it's x minus 2, you go 2 to the right. Because it's in the form of x minus h. So you're saying that h is negative. Just FYI. In this situation, you're saying x minus a negative 1, right? Minus a negative 1. So you're basically saying that h minus a negative 1 in this situation is a negative 1. So that one becomes to the left 1 unit. Okay. Question on that one, guys. Not too bad, right? Okay, so let's look at this one. I'm going to do this one. Okay. I did that one up there. We'll do this one here. So let's compare. the graphs. So here it goes. The parent function goes like this. It goes through 1, 1, 1. Okay? It goes through 1, 1 and negative 1, 1. Now, what does this one do here? What? Just looking at this one, remember, it's x minus h form. And h in this situation is 3. Is it 0? So it can become 0. Christopher, right? Are you talking about this one right here? Or here? On slide A or slide B? Because I just saw your comment. Okay. So does it become a 0? So what it's asking me here is to compare this one in red to the parent function of x squared, right? So what this one does, you see that one right there? It's just going to say, hey, slide 1, 2, 3 units to the right. And please make sure it's 1 off, 1 up, 1 off, 1 up. Same width. Okay? Just let it 3 to the right. So x minus 3 squared. So the answer for this one is going to be translated 3 units to the right. Okay? Is it so that it becomes a 0? I don't understand that question, brother. Did I answer your question? Do you kind of feel better now that you see that one now? Is that better? Okay. Thank you so much for helping me out, man. I was kind of lost. So let's look at this one real quick. Oh, wait, no, not that one. Last example, guys. I know it's time to go-ish. So the parent function goes like this. It goes through the origin. It goes through 1, 1. It goes through negative 1, 1. You got to know that. And that's the parent function of x squared. This one now, which way does this one go, guys? Come on, talk to me. Which way does this one translate? Translates 2 units. Translates 2 units which way? Come on, talk to me. Anybody? Left. Excellent. Now, remember the form is x minus h. In this situation, I have a negative, so it's going to be x minus a negative 2. So I basically going to go to move that one 2 units to the left. 1, 2. Same width. 1, 1. Ooh, it goes to that one. And 1, 1 goes to that one. And there is my answer. Tomorrow, we're going to continue this, guys. And it's a combination of both things. Tomorrow, we're going to continue left, up and down, right, left. Questions over that? Your silence, guys. Your silence is killing me. It doesn't make me want to teach better or go more interesting. Yeah. You gotta help me out. Make it a little more back and forth-ish, all right? It'll be better for you and better for me. Well, guys, 11:45. Y'all have a good lunch. We'll see y'all tomorrow, guys. Jasmine, don't go yet. Sir, I think you don't understand it because you're doing translation, but I was doing the equation. You got numbers and you just plug them in or what? Jasmine, are you still here? Yes. Yeah, okay, I kind of got that at the end. But because it wasn't asking us to do that. You know what I mean? Like, that's what I'm saying. Like, I don't understand why you would do that. It was not asking us to get numbers and plug them in there. It was just saying, hey, use the graph. Look at the, it was basically saying, look at the way they write it, and you should know the parent function, what it looks like. And so when you get this other whatever looking at it, you should automatically kind of in your brain know what's happening. Oh, it's sliding it to the right. Oh, it's going up. Oh, it's reflecting it down. Oh, it's thinner. Oh, it's wider. That's what they want. But with today's technology, you really just have to graph it in the calculator. A lot of y'all won't even want to pay attention to this section here because I'm going to graph them both in the calculator so I can tell the difference. You know what I mean? It's a cool trick. knowledge is power. I don't blame you if you don't want to, because if I would honestly always use my calculator. Cool? Hey, no worry. You're good, Jasmine. No worry. Jasmine, can I ask you, how are you on Alex? Are you done with all the Alex or no? Do you feel like is it too much already? Not enough? Are you fine with it?